This is an instructional video on angle pairs using algebra, and it's a practice review on problems 5 through 12. Number 5, the first thing you need to do is identify the relationship that your angles have with each other. These angles are both inside the parallel lines and they're on alternate sides of the transversal, so they are alternate interior, which means they are congruent. So you're going to set these equal to each other. So you would have 9x plus 2 equals 119. To solve your two-step equation, subtract 2 on both sides, leaving you with 9x equals 117. And your final step is to divide both sides by 9, so x would equal 13. Number 6. These angles are both on the inside of the parallel lines. One of them is obtuse, one of them is acute, which means these are supplementary angles. And supplementary angles equal 180 degrees. So we're going to need to set these two things, add these together to equal the 180. So 12x minus 8 plus the 104 equals 180. At this point, you want to combine your like terms, the negative 8 and the positive 104, and that's going to leave me with the 12x, positive 96, equals 180. To solve your two-step equation, subtract 96 on both sides of the equal sign, and that's going to leave me with 12x equals 84, and your last step is to divide both sides by 12, so x would equal 7. Number 7. First, identify the relationship of your two angles. They're on the outside of the parallel lines, which means they're exterior, and they're on alternate sides of the transversal, so they're alternate exterior angles, which means they are congruent. So we're going to set these equal to each other. So 5x plus 7 equals 8x minus 71. So then we want to get our variables on the same side, so I'm going to subtract 5x on both sides. That'll leave me with 7 equals 3x minus 71. We want to get our constant to the other side, to the left side, so we're going to add 71 to both sides of the equal sign. So that would leave me with 78 equals 3x. And then our final step is to divide everything by 3. So x would equal 26. Number 8. Look at the relationship of the angles you're missing. They're both on the same side of the transversal. They're both on the top side of the parallel line, so they are corresponding, which means they are congruent. So those are congruent. We're going to set them equal to each other then. So 4x minus 7 equals 7x minus 61. Then we want to get our variables to the same side of the equal sign, so I'm going to subtract 4x on both sides. That's going to leave me with a negative 7 equals 3x minus 61. Then I want to get my variable by itself, so I'm going to add 61 to both sides of the equal sign. So negative 7 plus 61 would be a positive 54 equals 3x. And then your final step is to divide by 3 so that you can figure out what x equals, and x equals 18. The remainder of the problems we're going to work are going to be more complex problems where there's more than one variable. So when you're doing these, you have to focus on one of the variables at a time and also look for those angle relationships. So on this one, we're going to start with our first step, which we're going to solve for the x. And we know by looking at our angles that the x's are both on the left-hand side of the transversal. They're both on the top side of the parallel lines, which means they are corresponding. So we know they are congruent. So we're going to set them equal to each other. So that would be 9x plus 25 equals 13x minus 19. I'm going to start by subtracting 9x on both sides of the equal sign, leaving me with 25 equals 4x minus 19. I need to move that 19 to the other side of the equal sign, so I'm going to add 19 to both sides so I can isolate that variable. 25 plus 19 will give me 44 equals 4x, and then divide by 4. So x is going to be 11. So now I know what one of my variables equals. But in order for me to work my problem, I'm going to need to figure out what this angle measurement actually is. So our second step is going to be to substitute x equals 11 into the 13x minus 19. So that's going to look like 13 times 11 minus 19. That will give me 143 minus 19, which ends up equaling 124. So what that measurement does is it gives me the value here, 124. I know that these measurements are supplementary. They make a straight line. I know that supplementary angles equal 180 when they're added together. So that is my third step to solve for the y. So I'm going to take the 17y plus 5 plus the 124 angle that I just came up with. Sorry. It's 124. And set those equal to 180. At this point, I do want to combine my like terms. So it's going to leave me with 17y plus 129 equals 180. I want to subtract 129 on both sides of the equal sign so that I can isolate the variable. So that leaves me with 17y equals 51. And then finally, I need to divide both sides by 17. So y would equal 15. You just have to take it a piece at a time and pay attention to the relationships of the angles as you go through the problems. Make sure you get an answer for both of your missing variables. Problem number 10 is another complex problem. You have the variable of x and the variable of y missing. We are going to start our steps with step 1 of solving for the x. We're going to solve for x because these angles right here are both interior angles inside those parallel lines. One of them is obtuse and one is acute, so we know they are supplementary. So we know that they're going to add together and equal 180. So we're going to take those two measurements, 6x minus 7 plus the other angle of 3x minus 29, and set them equal to 180. You want to combine your like terms, so 6x plus 3x would give me 9x. I then want to take my negative 7 and my negative 29 and combine them, and that would give me a negative 36 equals 180. At this point, I want to get my variable by itself as much as possible, so I'm going to add 36 to both sides of the equal sign. That's going to leave me with 9x equals 216. And my final step for the x is to divide both sides by 9. And that gives me the fact that x is 24. Now, my second step is going to be to substitute the x equals 24 into the angle right here, because these angles here and here are vertical. So that's the reason I want to substitute into the measurement of 6x minus 7. Okay, so we're going to start that process. 6 times 24 minus 7. 6 times 24 is 144. That minus 7 is 137. So that lets me know that angle measurement. I'm going to take those off. So I know the measurement here is 137. So my final step on this one is to solve for y. And we know we can do that because we have vertical angles. And we know those are congruent. So I can take the 8y plus 17 and set it equal to the 137 and solve for that y. So I'm going to subtract 17 on both sides. 8y equals 120. And then your final step is to divide both sides by 8. And y equals 15. Okay, when you first look at this problem, it looks extremely overwhelming. So let's just identify some things we know. We know that the 3x right here is vertical to the other angle on the opposite side. So this also is 3x. Same thing with the 49. The 49 is vertical. So I can put a measurement of 49 right here. We know that these angles right here are going to be alternate exterior to the angle up at the top. So that's going to be our first step. We're going to solve for x. And we know we can do this because they're alternate exterior. So we're going to have 3x plus 49 equals 7x minus 23. We want to get our variables to the same side, so we're going to do minus 3x on both sides. That will leave me with 49 equals 4x minus 23. I want to get my x by itself, isolate that x, so I'm going to add 23 on both sides. And that would end up leaving me with 72 equals 4x. Now to isolate the variable, divide both sides by 4, and x equals 18. So that's an important piece of information. We have to find the measurement of both the x and the y. So at this point, we want to take and substitute the x equals 18 into, let's see, we're going to substitute it into this measurement. So step 2, substitute. So we're substituting into that 3x angle, and we're doing that because this angle of 3x right here is related to this angle. There's a relationship there. So if I can figure out the measurement of 3x, then I can set those equal to each other and solve the rest of my problem. So our problem here now is 3 times 18, and I know that 3 times 18 is 54. So this measurement actually is going to be 54. So our final step on this problem of number 3 is going to solve for the y. And we know those are corresponding. The 54 degrees. It corresponds to the 54 degrees. So that's going to give me 11y minus 1. That's going to be equal to 54 because corresponding angles are congruent. We want to add 1 to both sides, which leaves me with 11y equals 55. And then your final step is to divide by 11. So y equals 5. So what started out as a very complex looking problem ended up being fairly easy to solve. Problem number 12. We are going to start this problem by solving for the x first because these x values here are alternate interior. So solve for x, alternate interior. We know alternate interior angles are congruent, so we can set those equal to each other. So 5x minus 38 equals 3x minus 4. We want to get our constants all to one side, our variables all to the other side. So we're going to start by subtracting 3x on both sides. That's going to leave me 2x minus 38 equals negative 4. I want to isolate my variable term, so I'm going to add 38 on both sides. So 2x equals 34. And then my final step is to divide both sides by 2. So that leaves my x equaling 17. So my next step is we're going to take the x equals 17 and we are going to substitute it in to the 3x minus 4. So we're going to substitute, and I'm just going to shorten that. The x equals 17 into the 3x minus 4. So that would be 3 times 17 minus 4. 3 times 17 is 51 minus 4, which ends up being 47. So that lets me know that this angle measurement here is actually 47 degrees. So what I'm going to focus on now is finding this measurement here, and I can do that because this whole thing makes a straight line or a straight angle, and we know that those equal 180 degrees. So we're going to solve for the straight angle, also called a straight line. We know that this measurement with the little square in it is a 90-degree marker square, so it's 90 degrees. So we have 90 degrees plus the 47 we just solved for. And when we add those together, we end up with 137. We're going to take our 137 and we're going to subtract it from 180 because we know straight angles equal 180 degrees. So we're going to subtract that, and that's going to give me 43. So that lets me know this angle measurement is 43. So once I've done that, I can look at this measurement and this piece. They are alternate interior angles, so I can set them equal to each other. So our step number 4 is to solve for the y. Again, they are alternate interior, which means they are congruent. So that would look like 7y minus 20 equals that 43 degrees measurement we came up with. We want to isolate our variables, so we're going to add 20 to both sides. So that would leave me with 7y equals 63. And then divide both sides by 7 to get the y by itself. So y would end up equaling 9. So now you have both your x and your y measurements that you need.